Alright, today's video is about solving absolute value equations. So our objective is students will be able to solve absolute value equations. As just a reminder, let's talk really quickly about what absolute value is. So if I ask you, what is the absolute value of -3? That's asking us, how far is -3 from 0? And if I were to count 1, 2, 3, it is 3 away. So the absolute value of -3 is 3. Something to remember is that absolute value is always positive. We read absolute value as the positive distance that a number is from 0. Whether this is the absolute value of 3 is going to be a positive 3, and the absolute value of -3 is 3. Alright, so let's do some examples. So I have the absolute value of n equals 3, and the absolute value of x equals 9. Now, we don't know what n is, but a couple of things could happen. This could have been the absolute value of 3 is 3. The absolute value of 3 would be 3. But we also could have had a -3 in there. The absolute value of -3 is also 3. Because either of these numbers will give us a solution of +3 because of these absolute value bars. There's a really important key point that we need to remember when solving absolute value equations, and that is that absolute value equations have two solutions. Absolute value equations have two solutions. N could be 3, or n could also be -3, because the absolute value of -3 is 3, and the absolute value of 3 is 3. So we will have two solutions, and we will write that n can either be 3, or n could be -3. Sometimes you'll see your solution written like this. Either way is fine. So what could the x be? Well, we know that the absolute value of x gave us 9, so we could have had the absolute value of 9. That gives us 9. Or we could have also had the absolute value of -9. So again, we're going to have two solutions. We could have either that n is 9 or that n is -9. And you could, again, see it written two different ways. Let's do another example. Alright, now we're dealing with some operations, and we know that there's going to be two solutions to every absolute value equation. We just learned that. But now we have some stuff going on inside of the absolute values, so we need to talk about another key point. Isolate the absolute value bars then find two solutions. And I'll talk about what that means in just a second. You need to isolate your absolute value bars and then find the two solutions. So I'm looking at this problem, and right now I have the absolute value of b plus 9 is 11. This b could be a negative number. This b could be a positive number. We don't know. So once we have these absolute value bars isolated, there's nothing on either side of them. There's nothing on the outside of them. We can take our two solutions. And the way we're going to do that is to physically take this twice. So one of them is going to be b plus 9 equals 11. That's my first solution. My second is going to be b plus 9 equals -11. And the reason is we're using inverse operations, and we change our answer to negative because this number could be positive or this number could be negative, and we don't know what is going to get us to a positive 11. So now I'm going to go ahead and solve. So b plus 9 equals 11. I'm going to subtract 9 from both sides. I bring down my b. My 9's cancel out. 11 minus 9 is a positive 2. I'm going to solve my second equation. Subtract 9 from both sides. Bring down my b. -11 minus 9 is going to give me a -20. A -20. So now I have two solutions, that b is 2 or b is -20. Now, just to show you that this works, let's plug each of these back in and check it. So here's my first one. The absolute value of b plus 9 equals 11. Let's see if that works for the first one. Is 2 plus 9 11? Well, the absolute value of 2 plus 9, that's going to be the absolute value of 11. Is the absolute value of 11 11? Yes. Let's check our second one. We had the absolute value of b plus 9 equals 11. Let's put in negative 20. Is negative 20 plus 9 give you 11? Well, negative 20 plus 9 gives you negative 11. And what is the absolute value of negative 11? It's 11. So we did our work right. Our solution is going to be b is 2 or b is negative 20. So I can either write b is 2 and that b is negative 20, or I could write 2 comma negative 20. Let's do another example. I have 10 minus 3x equals 8. Again, I want to look, okay, do I have any operations going on the outside? No, so I can go ahead and take my two solutions. So one is going to be 10 minus 3x equals 8, and the second will be 10 minus 3x equals negative 8. I'm going to go ahead and solve. I'm going to subtract 10 from both sides. These cancel out. I'm left with negative 3 equals negative 2. I'm going to divide both sides by negative 3. We're left with x equals negative 2 divided by negative 3 is going to give me a positive 2/3. Let's do this one. I'm going to go ahead and subtract 10 from both sides. These cancel out. Bring down my negative 3x. Negative 8 minus 10 gives me a negative 18. I'm going to go ahead and divide both sides by negative 3. So x is going to be equal to negative 18 divided by negative 3, which gives me a positive 6. Let's go ahead and just check to make sure that this works. So is the absolute value of 10 minus 3x 8? Well, let's try our first number. Is 10, the absolute value of 10 minus 3 times 2/3 give you 8? Well, negative 3 times 2/3 can give you a negative 2. 10 minus 2 is 8. And what is the absolute value of 8? It's 8. That works. Let's try our second. Let's try our 6. Is the absolute value, so 10 minus 3x equals 8. Let's use our 6. Is 10 minus 3 times 6 8? Well, 3 times 6 is 18. 10 minus 18 is negative 8. What is the absolute value of negative 8? It's 8. It works. So our solution is either going to be that x is equal to 2/3 or x is equal to 6, or we could write 2/3 comma 6. Let's go ahead and do a little more complicated example. Now, we just talked about how you need to make sure that the absolute value bars are isolated before you try and find the two solutions. So a key point here that we need to write down is to isolate absolute value bars. I'm going to write it down again. Then find two solutions. And that's really clear in this problem because right now our absolute value bars are not isolated. We have this minus 5 over here. So we need to get rid of this first, and then we can find our two solutions. So how do I undo minus 5? I'm going to add 5 to both sides. I'm going to bring down the absolute value of 2x. 9 plus 5 is going to give me 14. Now that my absolute value bars are isolated, I can go ahead and solve for x. So I'm going to have two solutions. 2x equals 14 and 2x equals negative 14. So I'm going to go ahead and divide both sides by 2 to solve for x. So x could be 7. I'm going to divide both sides by 2. So x could be negative 7. Let's just double check to make sure that that works. is the absolute value of 2 times 7 minus 5, 9. Well, 2 times 7 is 14. What's the absolute value of 14? It's 14. What's 14 minus 5? It's 9. It works. Let's check our second one. Is the absolute value of 2 times negative 7 minus 5, 9. Well, 2 times negative 7 is negative 14. The absolute value of negative 14 is 14. 14 minus 5 is 9. So it works. So our solution is either going to be that x equals 7 or x equals negative 7, or we could say that 7, negative 7. Let's do a couple more examples. Again, we have the absolute value of n plus 5 divided by 3. I can't find my two solutions until I get this isolated, so I need to get rid of this divide by 3. How do you undo divide by 3? You multiply by 3. These 3's cancel out. I'm left with the absolute value of m plus 5 equals 12. Now that my absolute value bars are isolated, I can go ahead and solve. So I'm either going to have m plus 5 equals 12 or m plus 5 equals negative 12. To get m by itself, I'm going to subtract 5 from both sides. So m is going to be equal to negative 7. I'm sorry, n is going to be equal to 12 minus 5. I thought that was a negative 12. 12 minus 5, which is 7. So my second equation, I'm going to subtract 5 here. These 5's cancel out, and we're left with m equals negative 12 minus 5, which is negative 17. Let's really quickly check our solutions before we go any further. So, is the absolute value of 7 plus 5 divided by 3, 4? Well, the absolute value of 7 plus 5 is going to give us 12. What's the absolute value of 12? It's 12. And 12 divided by 3 is 4, so it works. Let's try our second one. Is the absolute value of negative 17 plus 5 divided by 3 give you 4? Well, negative 17 plus 5, that's going to give us a negative 12. What's the absolute value of negative 12? It's 12. 12 divided by 3 is 4. So our solution works. So our solution is either going to be that m is 7 or m is negative 17, or we could say that m 7 or 17. We're going to do two more examples. So right here we have negative 6, and we have absolute value large 5x. Now, even though this is touching, this is still something that we need to get rid of. We still need to isolate these bars. Remember that absolute value bars are like grouping symbols, and when you see a number and it touches a parenthesis like that, if it was parentheses, you would know that you are multiplying here. The same concept applies for absolute value bars. So what's actually happening between the negative 6 and the absolute value 5x is it's being multiplied. So how do you undo multiply by negative 6? You divide by negative 6. My negative 6's cancel out. I'm left with the absolute value of 5x equals negative 120 divided by negative 6, which gives you a positive 20. Now that my absolute value bars are isolated, I can find my two solutions. So 5x equals 20, and 5x equals negative 20. I'm going to go ahead and solve for x. So divide both sides by 5, and I get that x equals 4. Divide both sides by 5, and I get that x equals negative 4. Let's very quickly check our answer, make sure it's correct. Is negative 6 times the absolute value of 5 times 4 give you negative 120? Well, 5 times 4 is 20. The absolute value of 20 is 20, so I'm going to drop the bars, but replace them with parentheses. because it's important that we remember that we're multiplying. Negative 6 times 20 is negative 120. It works. Let's try our second equation. Negative 6 times the absolute value of 5 times negative 4. Does that give us negative 120? So I'm going to bring down my negative 6. 5 times negative 4 is negative 20. The absolute value of negative 20 is 20. And negative 6 times 20 is negative 120. So it works. So my solution is going to be that x equals 4, or x equals negative 4, or 4, negative 4. Alright, now this one's got a whole lot of stuff going on. We need to get our absolute value bars isolated. We have it being multiplied by 9, and we also have to have it added by 8. Remember that when you're solving something, whether it's an equation, whether it has absolute value bars in it, you're going to use reverse GEMDAS. So first thing we're going to get rid of is any addition or subtraction. So I notice that we are adding 8, so I'm going to subtract 8 from both sides. I've not done anything with this. I'm going to go ahead and bring it down. 9 times the absolute value of 5 minus 5b. This cancels out, and that's going to be equal to 53 minus 8, which is 45. My absolute value bars are still not isolated. I still have this times 9 here, so I need to divide both sides by 9. These 9's cancel out. I'm going to bring down the absolute value of 5 minus 5b is equal to 45 divided by 9, which is 5. Now that my bars are isolated, I can do two solutions. My first will be 5 minus 5b equals 5. And my second will be 5 minus 5b equals negative 5. I'm going to go ahead and solve. Subtract 5 from both sides. Negative 5b equals 0. Divide both sides by negative 5. So b equals 0. Second one, I'm going to subtract 5 from both sides. So negative 5b equals negative 10. Divide both sides by negative 5. So b is going to be equal to 2. Let's check our solution, especially here when this is a big complicated problem. So I had 9 times the absolute value of 5 minus 5. B was 0. That was my first one, so let's use that one first. Plus 8 is 53. So, well, 5 times 0 is 0, and 5 minus 0 is going to be 5. So I have the absolute value of 5 plus 8 equals 53. We can go out, this is simplified now, so I can drop my bars. What is the absolute value of 5? It's going to be 5. 9 times 5 is 45, plus 8 is 53. Let's try the other side. 9 times the absolute value of 5 minus 5 times 2 plus 8. Does that give us 53? Well, 5 times 2 is negative 5, and 5 times 2 is 10, and 5 minus 10 is negative 5. This is isolated now. There's nothing on the inside to simplify, so we can go ahead and take away our bars. What is the absolute value of 5? It's 5. So 9 times 5 plus 8. 9 times 5 is 45, plus 8 is 53. So 53 equals 53, so we're correct. So our solution is going to be that b equals 0, or b equals 2, or we could write 0, comma 2. Let's do one more example. Oh, actually, that was the last example. So, now we have some practice problems. I want you to go ahead, pause the video, try these practice problems, and then when you're ready, you can go ahead and see the answers. Alright, here are the answers. Be sure that you check that you have the right sign, write down any questions you have, and come to class ready to practice.